example and just show you some things that you're going to, it will take a little bit of time to master, but you'll get the hang of it. So here we go. We're going to start off with a different alkane, and this alkane structure has 2 carbons in it, and their bond fulfillment comes from 3 hydrogens added onto each carbon. So when I take a look at this, here is my parent chain. So this parent chain, the only carbons that I can circle, it contains 2 carbons, so N equals 2. So when I go to table P, I know that this name, 2 carbons in a parent chain, we use the prefix F, and those bonds, those 2 carbons are linked together with a single bond. So this is our simple hydrocarbon ethane. So like in the previous example, I'm going to put this through a substitution. Okay, so the first substitution, so I'm going to put this through a substitution reaction, which means I'm going to replace one of the hydrogens. And like before, I'm going to replace it with a fluorine. So this fluorine is going to come in, okay, and it is going to kick that hydrogen off of the parent chain. So what I'm left with in the original structure, okay, I still have my 2 carbons single bonded. The first carbon on the left still has its 3 hydrogens. The second carbon has 2 of its original hydrogens, and now instead of its third hydrogen, there is a fluorine there. So like the one up above it that I showed you, okay, we keep the base of the the hydrocarbon name, so this is still ethane, but the structure is a little bit different than the straight up hydrocarbon, so the name needs to be a little bit different. So out in front of it, we need to put fluoro. So fluoroethane. Okay, so now I am going to put this structure through another substitution reaction, and I am going to once again replace a hydrogen with a fluorine. So this time, this fluorine is going to come in and kick this hydrogen out. So here we go. We have our 2 original carbons. The first carbon has 2 of its hydrogens. The second carbon still has 2 of its hydrogens. The first carbon now has a fluorine attached to it, and the second carbon also has a fluorine attached to it. So like the example that we did up here, it would be fluoro-fluoro, ethane. But because we have 2 fluorines of the same type, we can shorten the fluoro-fluoro down to difluoroethane. Okay, so now I'm going to continue on here. I'm going to do another example here. So I'm going to put this original fluoroethane structure through a substitution reaction down below. So I am going to put this through a substitution reaction, and I am once again going to replace a hydrogen with a fluorine from a fluorine molecule. So this time in the substitution, one of the fluorine atoms from the fluorine molecule is going to come in, but it is going to replace a hydrogen that's on the same carbon as the original substitution. So this time, what my drawing is going to look like is I still have my carbon to carbon. My first carbon still has its 3 originals, but my second carbon, it has the first substitution, fluorine, and now it has a second substitution. Now, like the example up here, it still is a 2-carbon chain, which makes it ethane with a single bond. It has 2 halogens attached to the structure. Oh, I see, I forgot a hydrogen there. Okay, so we have a fluoro, which I can also reduce down to difluoro. So now I have 2 structures here. These 2 structures, they are both right now named difluoroethane, but when you look at the bonds, they are not exactly the same. They have different structures. So we have to deal with that in the name to provide that. So that is where we need locations. So this idea here, if there's more than one location possible for a halide on the parent chain, we must provide the location based on the lowest N value. Okay, so let's take a look here. So this will take time. You might not get it right away. You will ultimately get this. It just takes time. So here we go. We go to our structure and we look at it left to right. Okay, and you number your carbons left to right. So here is carbon 1 and here is carbon 2. So left to right, red fluorine is on carbon 1, black fluorine is on carbon 2. You also need to renumber this from the right back to the left. So now this would be considered carbon 1 and this would be carbon 2. So looking at it right to left, I come to the black fluorine. It is on carbon 1, and when I continue on to carbon 2 where the red fluorine is, that would be 2. So looking at this structure, whether I look at it from the left or to the right, the locations on the parent chain carbons does not change. So here we go. So if we have 2 halocarbons on the parent chain and we have the prefix di, we have to have 2 location numbers, the parent chain carbon number. So out front, I put a hyphen out in front of the difluoro and I put 1, 2. So this would be 1,2-difluoroethane because these 2 fluorine atoms are on different carbons in the parent chain. We need to repeat the process with the example down here. So here we go. So looking at this left to right, this would be carbon 1 and this would be carbon 2. The black fluorine is on carbon 2. The green fluorine is also on carbon 2. I have to renumber this right back to the left. And so now this becomes carbon 1 and this is carbon 2. Black fluorine right back to the left is on carbon 1, and the green fluorine right back to the left is also on carbon 1. So now we have different designation numbers when we look left to right. So here's the thing. When you end up left to right and right back to left, you have a different set of locations. We always choose the lowest combination set. So here we go. 1, 1 is a lower set of designations than 2, 2. Because we have 2 fluorines, we have di, we have to have 2 location numbers out there. So this would be 1, comma, 1 difluorine. This tells us where each of the fluorals are on that parent chain. I'm going to do one more example here. So now I'm going to take this structure right here and I'm going to put it through another substitution. So this guy here we go. So this time I'm going to do a substitution reaction and I am going to replace a hydrogen in this structure with a chlorine from a chlorine molecule. So here we go. One of these chlorines is going to come in and it is going to kick this hydrogen out. So when I go to draw the new structure after this third substitution, I still have my 2 carbons that are bonded with a single covalent bond. This carbon still has its 2 of its original hydrogens, but now instead of its third hydrogen, it actually has a chlorine. The second carbon, it still has one of its original hydrogens, and it still has the green fluorine and the black fluorine. So when we take a look at this structure is still ethane, 2 carbon parent chain. We still have the 2 fluorines, right? So it's still difluoral. So I'm going to just put this down here because I got to write some stuff out. So I know here I still have ethane and it's still a difluoro. And now I have a chloro. Okay, so these are the things that I need to show in this question. So I need to do my numbering left to right. So here we go. This would be carbon 1 and this would be carbon 2. Well, on carbon 1, I have a chlorine. So that's carbon 1. And then the 2 fluorines would be on carbon 2 left to right. But I take a look at this right back to the left. I renumber. This is now carbon 1 and this is carbon 2. Well, my black fluorine is on carbon 1. Green fluorine's on carbon 1. When I look at this, the chlorine is on carbon 2. So when I look at my number designations, okay, I take a look and I go with the lower combination, 122 or 112. Well, 112 is the lower combination of designations, okay? So my difluorals, they are 1,1, and the chloro is on 2. Now, when I go up here, we've got to take a look at number 8. If more than one halide of different types are on the same hydrocarbon, okay, you put the halides in alpha order. So alpha would be something that's A, starts with an A, would come before anything that starts with a Z, so alpha order. So chlorine C comes before fluorine in the alphabet. So the final name of this one would be 2-chloro. 1, 1 hyphen difluoroethane. So this just gives you ideas of how you need to approach these. A little practice goes a long ways.